Last time we talked about how to get SQL started, MySQL, all that kind of stuff started. We got it started. Once it's started, then your first task is to create a database. And you can use the command create database. There's also create schema if you prefer to use the MySQL term. But I use create database. Database has to be created before you can generate any tables in it. This is usually a one-time bad deal. You create it and then you're done. So you need to know how to use the commands, but you don't use these commands very often. You can also show all the databases in MySQL. All your databases are listed over here in the navigator. So there's Alexamar, the one we built last time, and any of the other ones will show up here. And on my other flash drive, there are dozens here of databases that I play around with. So I don't usually need the show databases command to find out what databases are there. Even my Fat Cow site has a navigator, something similar to this, that shows me all my databases. So I know how to do the show databases command, but it's not one I've used very often. Drop database, on the other hand, I'll use that every so often to start over again, particularly in classes. After we've dropped some records, we could drop the database and completely rebuild the whole thing. That page that was up there when I first started was a SQL or a MySQL procedure, which is basically like a method. And it had command after command after command after command to create tables, throw data in them, do all that stuff. And so by just pushing the run button up here, I got to build a brand new database and all its tables and all of its data in one command. And you'll learn how to do that before we're done here. When you're ready to use a database, you do have to select it. You can enter the use database name command, or you can just come over here and double click it. Once it's bold, that's the database. Bold in the navigator, that's the database that you're using. Very common mistake is to say issue a command and it goes, I can't do that because the database doesn't have this table in it, or you don't have your database selected. If we create tables in here and I've got the wrong one selected, it'll create it right inside the CD column, and I'll have a nice list of marinas inside the CD column database. So be very careful. Make sure, at least while we're creating stuff here, the tables, that you create them in the right place. We talked about the create table command. In my notes, the dark blue capitalized are keywords, and you can't use those for other things, and they have to be there. But MySQL is not case sensitive. I normally type these all lowercase like I did back here. It's also not case sensitive when you're talking about field names. The only time it's case sensitive is when you're looking at data, and that depends on the database. MySQL, I'm trying to remember if it's case sensitive. If I'm looking for Volcker lowercase v, will it find it? We'll find out. But that's not anything to do with creating the table. To create the table, you use the keywords and then whatever you want to call the table. MySQL uses all lowercase. You can type whatever you want for marinas. It will create the table using all lowercase. We'll look through the documentation one day, and they said they do that for portability so that you can take this database from one place to another and not have to worry about whether it's case sensitive or not. So your database names and your table names will automatically be converted to lowercase by MySQL. Once we define and given the table a name, and I've stopped putting prefixes on my tables, whether you want to put prefixes on them, the TBL prefix is up to you. I'll accept them. I'm not doing that much anymore. Once we define the table name, then we start listing the fields and all of their different types, and that's kind of where we left off last time. When we define fields, the first field I typically define as the primary key. And in most of my tables, the primary key is called something ID, like student ID. Data type is probably integer. I designate it as primary key and designate it as auto increment. Notice it's auto increment, not auto number, not auto something. The increment does have the underscore in it. That's required. Not null is available for these other fields, but you don't normally use it on your primary key, because the primary key by default is not null. So you can't leave a primary key blank. Not null is just a way to tack that on the end here. You could say something like name varchar 30 not null. And that would basically mean you can't leave this one blank. then a new record. And you can't erase it if you're editing a current record. Jody, is that big enough for you back there?
Yeah.
Okay. Definitely not letting me, oh, there it goes. Control key. Okay. That better?
Yeah.
Yeah. Okay. I can make it bigger still, get one word on there. No, we don't want to do that. All right, so here's a typical create table command. We'll do this again in just a minute because the last thing we did last time was drop it. So it's probably gone. And we didn't complete it, so we need to learn how to do that. But here's a beginning of a table definition, create table marinas. The parentheses are required. The semicolon at the end separates one SQL command from another. You can have lots of SQL commands in this window, in this editor window. But if you hit the run button, the lightning bolt button, it will run them all. And typically you don't want to do that. You want to run only the current one wherever your pointer is. And if you do that, you use this lightning bolt or press Control Enter. Me that's dinging, sorry. Or press Control Enter and it will execute this command. So this one creates two fields. The first one called Marina ID. Notice that the field name comes first. That's a little backwards from what we're used to in C#. Field name comes first, then its type. We'll talk about all the different types today. And here's the primary key. Notice that that's spaced. And another space and auto increment. So there's my primary key. Every field has a comma separating it. Then I have another field called name. It's blue because it's a keyword, but that's okay. You can still use it as a field name. Doesn't cause problems. In this case, it's text, so I use the varchar type. We'll talk about the types in just a minute. And this 30 is how many maximum characters this field can hold. That all comes from your data dictionary. Somewhere you should have a design that says make the name 30 characters max. The not null would also be in your design to say this is a required field. I'm not a big fan of required fields, and if they are required, I typically take care of it in the GUI, not in the database itself. Questions on that? The describe command describes the structure. This is what I call the structure. What are the field names? What types are they? What's primary key? What's not null? Those kind of things. Those are called the structure of the table. The describe command will give you the structure of a table, whatever one you request. A lot of that information is also available over here in the navigator. Right now I don't have any tables because we dropped them. If you need to drop a table, there's the command. Again, that's not something I do a lot, but it occasionally comes in handy. That table, I messed it all up, or I want to start over again and practice again. I can drop it and start all over again. So at this point, I have nothing in my Alexamara database, so I'm going to start over again. Even though it was just there, I'm going to type the create table command. And I am using Alexamara, so make sure that your Alexamara table or database over here is selected. And then issue the create table command. And I usually put in a parenthesis and move down to the next line, but before I forget, I close my parenthesis, just like the curly brackets in C#. Use a close parenthesis, put the semicolon in there so that this is all ready, and then go in between. My first field was my ID, so this is the Marina ID. It's an integer. It's the primary key, and it's auto increment. At this point, I'm going to jump into my notes because I have my database design, or at least a haphazard one, at the end of this chapter. So let me jump to that real quick. So much for real quick. Okay, so here's my design. The next thing I want is the name size 20. So what we need to do is pick a field or pick a field type for that. Let's talk about all the different types that are available. Here they are. The most common type, period, is varchar. That's a text type. Many databases have lots and lots of text fields. Most of those are varying in size, like first name, last name, address, city, course name, program name. All of those are varying in size. Varchar is the appropriate type for that. Var stands for variable. It's a variable size text field, character field, and you designate the maximum size that this can hold when you build it. There's another type of character called char. This one is a fixed size field. If you designate a size of 5 and you only put 4 characters in there, it automatically fills with a space. And there is a space there, which is very annoying when you're searching because you can't search for Lyle. You have to search for Lyle space if for some reason somebody put it in a char field. So the only time I ever use char fields is if it's for a field that has a fixed size, that is always going to be that size, like zip code, like state code, like phone number. If it's always going to be 10 characters, then I use a char. If it varies, then you should use varchar. Otherwise, your searches fail. And that was real annoying the first time I figured that out because I couldn't figure out why I couldn't find it. I'd take a look at the entire database and say, yep, there's my record. And then I try to find it, and it wouldn't find it. It's because it was defined as a char. So only for fixed size fields. If you need big amounts of text, these are the equivalent of what many of you in your designs put in as memo. Microsoft Access now has long text as well. These store lots and lots of text, up to 64,000 characters. That's a lot. Up to 16 megabytes in one field. That's 16 novels in one field. Probably don't need it. The systems implementation class did a little research. Reen, you were part of that research, right? What'd you decide that anything up to about 500 characters, you're better off with varchar? It's more efficient. Okay, so those exist, but even for your description fields in your databases that you're building right now, you might want to go with just varchar 200, varchar 150. Okay. Sounds huge, but that's not a lot of characters. And I think they determine as long as you're under about 2,000, you're okay. So those exist. You might see them, but we're not going to use them. There's a date time type that allows you to store dates and times. If you just need dates, it has its own type. If you just need times, it has its own type. Integer we've already seen. You can type it all out if you wish, but I just usually abbreviate it. There is a small int if you really want to save a lot of space, but most people are telling me they don't bother. The downside to using small int is when you write a GUI that reads this, it has to be a small int on the GUI side, which just makes things more of a headache for a byte or two. And so my mentors are telling me that, nope, just go with int, you're fine. The int size will handle up to 2 billion, roughly. If you need something bigger than that and you still want an integer, there is a big int type, but again, that's not something I'm normally counting things more than 2 billion. So int covers it for me. And it's a quick fix if you need to change it. If your number has decimal places and you use either decimal or dec, followed by, first of all, the number of digits total in the number. And then Q is my little placeholder here for the number of digits after the decimal place. So if I wanted to store somebody's hourly salary and nobody in our company gets more than $100 an hour, I could store that as a decimal 42. 4 digits total, 99 and 99 cents. 4 digits total, 2 of them after the decimal place. In this language in SQL, you don't count the decimal place. Remember last semester when we were trying to line stuff up and we were using the string format command, I said you got to count the decimal place and the percent sign and the negative signs and all that stuff. Not in SQL. In SQL, you just count the number of digits and then how many of them should be after the decimal place. There's also a Boolean type. Occasionally you'll see that designated as bit, because bits are either 1 or 0. I typically use bool or boolean. And in some cases, the database program itself will change it to a tiny int, which I don't have listed here, which is really just one column in a memory location. If you have a true-false field, it should be designated as boolean. Now, having said that, in one of those databases, paperback, so that would be Henry Books, there's a field that's paperback or isn't it? That, to me, ought to be a boolean field, but I left it. They have a Y or an N in there. That's very common. Boolean would probably be better. I left it for a reason because we're going to change it in Unit 6. So if you're wondering why there's a yes/no field in there that's not designated as Boolean, it's a learning exercise. So those are the different types that are available to you. So now for each one of the other fields that we have here, we have to pick the appropriate type. Most of them are going to be pretty easy to figure out. So our next field will be the name field, but to separate your fields, don't forget the commas. I put them each on a separate line. I indent them for the same reasons that you indent in programming to make things a little easier to read and understand. Or in your case, so you don't make me angry when I'm grading. I've seen some people just like to string these all out, big old long line. I can see it on my 24-inch monitor with a size 8 font. What's your problem? Well, I'm old. Plus, this makes it a little easier to maintain. So names are varchars, right? And my design over there said 20, so we'll go with it. Follow your design. If you think it should be bigger, then go talk to the designer. Next one, address city. So let's do both of those. It's also a varchar. And for the address, I have it. Let's just slide this over. That might work. Don't get smaller. Address 15, city 15. So we'll just go with what they said. If yours are different, your designs, don't worry about it. Some of you are working on database design too. There's Alexa Mara in there. Noting the evil instructor here, I probably changed the numbers anyways. So when you put your numbers in, think logically, is 15 enough for an address? Probably not, but that's what we'll go with here. City, varchar, 15. You just keep listing these as we go. Next, we have the state, but the state is a field that does not change, whose size does not change. We're using a state code here, so I'm going to use a char. If somebody types in a state code, they shouldn't, right? Types in a state code, doesn't have 2 letters in it, why shouldn't they? They have a GUI that's validating it. Ought to be checking that. If they make one that's too short, we'll get a space on it and we'll have this weird state code W. And hopefully we'll be able to go fix that. But it's the GUI's job, I still feel, to fix this stuff. Zip code, same thing. I'm going with 5. We could, because that's what the design said, we could make this, how big for +4? 9. Don't store the dash. You'll see that in some databases, usually written by somebody with a little less experience than you have. Don't store the dash. We can always insert it later when we need to. And now that table's done. According to my design, those are the only fields we need to worry about. So at this point, anywhere, my cursor is anywhere inside that command, I can press Control Enter, and it'll execute it. And down below, I see my green check mark, so it should have worked. Now let's try that describe command just so that we can see it work, and describe this table, and it should echo all that back to us. Here's my primary key. Notice this one's automatically not null. I didn't tell it to make it not null, but it did it. It's auto increment. Everybody else has got the right stuff in there. And now you have a table. Let's do another one. You can close this window if it's getting in your way. Come down here where it says result 1, there's a little X that'll close the window. And I want to build another table. Over here we have marina slips, so I'm going to create table marina slips. I think I mentioned last time that my second year students are arguing with me about putting underscores in there to make it more readable. I think that's still readable. If you want to put an underscore in, I'm not going to argue with you, but then your examples when you're following me, don't forget to put the underscores in there whenever you reference the table. That underscore is part of the table name. Parentheses. Close parentheses, semicolon. Once again, Marina Slips has a slip ID, so that's an auto number field. Remember when you put your fields in, camel case them, because this does retain its capitalization. If I'd left that describe up there, you would see that the field names are still capitalized the way I type them. So type these properly. This is an integer, it's going to be the primary key, and it's auto increment. Many of our tables are going to look like that. Then I have a Marina ID field. That's my link, right? It's a linking field to the Marina table. It's an integer up here, but what it is not down here, and if you tried to do it, you'd get an error. It's not a primary key, and it's definitely not auto increment. It's only auto increment in the table where it's originally defined, where it is the primary key. Here it's a linking field, it is not auto increment. So that's all I need to put for that one. Then it looks like I have another one that links me to my owner. We haven't defined the owner table yet. Does that matter? No. As long as we ultimately define it, we should be okay. This is also an integer. We have a slip number, and if you look at some of the sample data that came in your book, that could be B1, it could be XY17. That's whatever the marina is using to put on the post. They say, here's where your boat is, you're in this slip number. Those are text, because they include characters. They may include numbers, but that's okay. It's like an address. It's text that might include some numbers. So the slip num. Then the next question I have to ask the owner is, does it vary, or is it always 4 characters long? It varies. The length of the slip so that we know whether or not a boat will fit in there. Have to ask the owner, is this a decimal or is it an integer? It's an integer. And the rental fee is obviously going to have decimal places in it. And I don't remember how big that was. Anybody? The rental fee? With some of the number, I think they were in the 1500s, somewhere around there. I'm just going to pop into my assignment real quick because I think I listed it there. Nope, select some more is the other one. Let's pretend it's 1500, somewhere in that range. That would be 4 digits plus 2 after the decimal place. That's the wrong one. Looks like they're all no more than 4 digits. Okay. So we need 4 digits on the left and 2 decimal digits on the right. So when you're trying to determine these decimals, if you see sample data, find the biggest number in there, and these are all 6 digits total. So this is a rental fee, its type is decimal 6. 2 of them after the decimal place. Now a common statement might be, shouldn't we allow for this database to be used 10 years from now and potentially we're charging $10,000 for a slip? Depends. You working in an agile environment? If you are, then the answer is no. Make it work for today. Don't worry about future problems. Who knows what your database is going to look like? So I would say no, make it 6.2, and in the future, if the price is going up, then we make it 7.2. We'll have to modify our program and everything, but those are our current requirements. Questions?
Slip number, does the N have to be small and lowercase to match the table or not?
Which number? Oh, this num here?
Yeah.
No, that's just a field name. You're asking because over here it's lowercase?
It's lowercase on the table. So.
No, it's not.
Yeah.
You're talking about this guy or this N right here, right?
Yes. On the table.
That's a field name. I get to pick it. Right? That's a field name.
It doesn't have to match the field name on the table.
Over here? That's my design. My designer didn't do a good job of camelbacking their stuff.
Well, I'm just looking at the table.
Oh, the one in the book?
Yeah.
I don't care. No. That's why when you look at your, if you look at your design, it's, oh, is it slip num lowercase n there?
Yeah.
Well, we know whose fault that is.
Well, so
I now have a new name. I'm the lame duck instructor. The lame duck instructor didn't capitalize it right.
owner number is also.
Okay. The reason those are that way, well, first of all, owner number I think went away. In the newest version of this, it's gone. Yes, it's gone. So there is no owner number. And here's slip num, you're right. I need to capitalize that. So we'll fix it. Thank you. Go ahead.
Is there a special command that we would use if we wanted to change the characteristic of a field label?
Yes, unit 5. Actually, there's a short version of it at the end of this unit. In case you make a mistake, you can fix it. But it's a whole unit on fixing fields and changing sizes and changing the data. There's a whole unit on updating a database, and that's coming. So for right now, try to be careful. And what I usually recommend to students is if it's wrong, do a drop table marina slips, change the N to capital, and rebuild it. As long as you haven't lost your SQL here, you could just re-execute that command.
What happens if you try to create a table that's already created?
You should get an error. That means it's already there. It's not supposed to be? Did you rename it Marina Slips?
No, marinas. I didn't drop it on the last one.
Okay.
So I have create table marinas. How do I just access the table instead of creating the table?
That's unit next. Well, actually, no, we're going to start entering data into it. If you want, you could do the describe to make sure it's set up right.
It's not.
This is my advice for this unit is drop it and then add the full version to it. So drop the table and then add it, particularly since we haven't put 5,000 records in there already. If we had added a bunch of records, then dropping it would be painful because the records go with it. But we haven't added any records. So in this case, if you make a mistake, you type 14 or 44 and you meant 4, my advice is drop it and then just re-execute this command. And if you've saved it, you can go pull it up from somewhere and then re-execute. If I hit the save button right now, I mean, you don't have to follow here, but I'm going to save this and I'm going to put it on my desktop for lack of a better place to put it. And I'll call this Alexa Mara. Notice the field type, the data type is already SQL. Save it. Now I can close this and I go, oh my God, it's on my desktop. This little guy up here, SQL open. Lets you open a file. There it is. And it's all back again.
So wouldn't it be the same if you just copied it and then?
You can copy and paste from one place to another. This is pure text. You got a notepad document. You can copy it from Visual Studio. I think the other day I was copying it right out of my notes. It's just text. So you can save it and restore from that. Good, Lau?
No.
If you have like a giant amount written and you haven't ran any of it yet, is it going to error out? Or?
It will error the way this is set up right now. We've basically created an SQL procedure. Do this and describe it. Do this and we don't have to describe yet. If any one of these errors, the entire script stops. The entire procedure stops. Unless you turn this little guy off here, then it'll run them all even if they fail.
But if we have a very large script, so we write, let's say that we write the whole table for the whole
You're
thing.
trained by Volcker. Why would you write the whole thing?
Just
Okay.
curious, if you throw it in there, is it gonna slowly work through all of it?
Yes.
Or is it gonna be too much information?
No. That one I had up here when class started creates, well, that was employees, so it creates 3 tables, including 50 state records and a bunch of province records and a bunch of territory records and 400 trip records, 50 employees. It's all one file. You push one button and you watch for 30 seconds and it's done. And we'll do that as well.
I have a syntax error.
Okay? You know what to do with that? Fix it?
Yeah.
All right, hang on.
Trying to see.
All right, I haven't executed Marina slips yet, so I'm going to do Control Enter. And Marina slips was successful. I got my green check mark down here. And remember, when you create tables, they don't automatically show up in the schemas over here. You have to ask for them by hitting the refresh button. And now my 2 tables are there. At this point, I can also select the tables and select the columns and see them. Comes in handy when you're doing homework. Can't remember what the fields are called. You can also select one of them, and down here it'll show you the details. So if you don't want to do a describe, you just want to see one. Okay. Why is this int 11? Because that's what MySQL translates int to. Don't define them that way, because you don't know that 11 isn't going to change in the future. I want the default integer, whatever it is. It's reporting int 11 right now, but if we looked at this 6 years from now, it might report int 24. Who knows? So when you declare them using just a straight O int and let the program itself determine how big that's supposed to be. I don't put sizes on my integers. Go ahead.
So if you save that and then you open it from your desktop or wherever you saved it, would it have the ones that you executed before?
If you keep them all, yes, I kept them. All right.
So like if you save like a table job, then it'll have that when you open it too?
All I'm saving is the text. The database itself is stored someplace else. All right. This database, remember, is stored in your XAMPP folder. Let me see if I can bring that up here real quick. You don't have to follow along. But this database is sitting in XAMPP MySQL data. And there's my Alexamara database. And then you look inside there, and who knows what the heck that stuff is. Okay. But they are stored there. So once I've executed the command, the database is stored. All you're saving when you hit save here is this text. As soon as you execute the command, as soon as I said execute this command, this database, or this table, excuse me, was created permanently. It is now, unless I drop it, yeah. It is now part of this Alexamara database, period. If I close all this and never save it, the database is still there. All I've lost is the command that I issued to create the table.
Well, what I meant was, let's say you save it, so it.
What am I saving?
You just save the file after you run it. So then it's all updated on the database, right?
Correct.
Then you open it from your desktop and then
Open what? The file.
the file.
It's text.
And then it'll have the text that has the drop. So you have to delete that if you want to run
Yeah,
it again.
if you've got a drop in there,
So
do I still
otherwise-
have the drop in there? No. But if
Otherwise-
you had the drop in there, and if you ran the whole thing,
Then it'll
Yeah.
still not.
I don't normally do that. If I have a file like this that's huge, there's maybe one command in there and I want to put my cursor on it and run just that one command. Okay. On the other hand, that file that was here before is designed to build an entire database in one file. It does everything we need to do. So yeah, if you run the whole thing using the regular lightning bolt here, yeah, if there's any drops in there, they'll show up.
So how do you run just like that?
Just click it and use the other lightning bolt. Okay, let's keep building. Now I need an owners table. Whether you save this text or not is up to you. Now, for me, when you're doing a homework assignment, that's how I ask you to save your homework assignments. Just keep typing until you get to number 21 or whatever the last one is. Then save it. Some of you keep going then and say, okay, now it's time for Henry Books. Typing. You just keep going. Or you can save Henry Books in its own file, and Premier Products in its own file, Lexomar Marine in its own file. Depends on when you save, and you can open them separately. So these are just like Word documents. They are commands to execute, to create tables, but you have to execute. All right, so for this one, we have an owner ID. Again, it's an integer, primary key, auto number, increment, excuse me. Last name, first name, phone number. You can see them up there. Keep going. Wow, don't put a comma there.
I fixed that on all of them.
Questions? I screwed up. So did all you lemmings. If you don't have a question, you followed me. We screwed up. What did we do wrong? Karen? Karen?
The phone number.
Yeah?
If you leave it like that, then, is that so they can?
Are you supposed to write
Or
char on it? Just
maybe
char.
just be char?
Should be char. If I make it varchar, that means I could have a 7-digit phone number and it won't complain. But what I've been doing in most of my databases recently is making all the phone numbers 10 required digits. Give me an area code. Since all the digits are required, char is probably a better solution for that. Okay, let's do one more. Now this one's a little different though. What I didn't include in my sample database over here is a services table, just to save time. Okay. So this table is actually a linking table. It links services to slips. What did I do? Okay. It's a linking table. If it's a linking table, these are probably both primary keys. I now have 2 primary keys. When you have 2 primary keys, you cannot say service ID primary key followed by slip ID primary key. You can't do that. If you have multiple keys, you have to use a different technique. If you have a multi-part primary key, you list all the fields but with no primary key designations. If it's a multi-part key, there's no auto number. If there's an auto number, that's the key. Done. If it's a multi-part key, there's no auto number, and you don't designate primary key. So we're just going to list all these fields. And then after the last field, we put the command primary key and then list as many fields as we need to.
So you'd have to type the command first before.
Yep, we do all of these things. So let's put those fields in. And all of these fields are simply integers, or not all of them, but the service ID is an integer, but you don't designate primary key here because it's a 2-part key. You can't designate auto increment, or you shouldn't, because it's not going to be auto increment. The service ID comes from another table. There's a slip ID that comes from another table. There's a description. It's going to be a varchar 150. There's a service date. which will be a type date. I don't care what time it was performed, so it's just a date type. And finally, there's a complete, and that's going to be a Boolean field. But now we need to designate the primary keys. So you do put another comma here. Say, I'm not done yet. And then you say primary key. Key, no S, even though there's multiples, it's just a key. And then in parentheses, which fields? My service ID and my slip ID are both part of my key. Then there's no more comma, and there is a semicolon down there. It is perfectly legal. You'll occasionally see it, that even if there's only one key, you designate it down here at the end. I don't like to do that, particularly not with auto increment fields. I like to designate primary key, auto increment all on one line so I can see it. I only use this technique when I have multi-part keys. But it is legal, even if there's only one, to tuck it down underneath here. And you just say primary key customer ID or whatever it is. Questions? Control Enter. Good to go. So now if I refresh my table list over here, I've got all of my tables. What happened to owners? Must not have ever executed that one, huh? Okay. Now I have my 4 tables. This is how you build the structure of a database. Again, you should have a design, should have a data dictionary somewhere to help you with this, and that's why you're doing the database 1 and database 2 assignments. Hint, hint, do not really build in SQL unless you're just doing it for practice, because I am not going to assign those to you. So when you get the database design done for Alexamar and Premier Products and Henry Books, you can practice if you wish, but you don't have to build them for me. Primary reason is because I want us all to have the same design, and you all could be picking different field sizes, right? Because I didn't tell you what size to make these things. I have a different exercise for you to do to practice for this chapter. And I'm going to give you Alexamar, Henry Books, and Premier Products with all the data in it and everything for free. I'm going to put in a tip jar, though. Any questions about building? Okay, at this point might be a good time to save. So I'm going to save. And mine already has a name, so you could save yours as Alexamara design or Alexamara structure. I could close it and start over, but I kind of like having field names handy because we're now going to start filling it with data. So it's nice to have these somewhere nearby, though I could notice down here when I have the marina slips selected, I get to see all the field names. So let me change my mind. Once you've saved it, close it. Now you got a nice fresh screen for the next batch of commands. And we'll use this feature down here. It's kind of hard to see on mine, but you should be able to see the same information down here about the fields in the table. So that's how you build the structure. There's the different types. Here's an example. Okay, again, these are all capitalized just to make the words stand out. We didn't do any not nulls. I'm not going to require it. Unless my assignment, I don't think it does, says make it not null or make it required. If I don't tell you to, you don't have to. And I recommend you not do it. Leave it for the GUI. It's a business rule. It doesn't belong in the database. What about foreign keys? It is possible in MySQL to designate one of those keys, like the linking fields, owner ID and the slip, that kind of stuff. You can designate them as foreign keys in your database definition. Why would I do that? It's a good question. The only reason I would do it is to prevent the database from breaking referential integrity rules. Remember, referential integrity means you have child records without a parent. I've got orders, but no customer. Doesn't make any sense. If you designate foreign keys, the database, MySQL, will go, I'm sorry, no, I'm not deleting this because you have child records. The database will prevent you from doing that. This is also a business rule. Jason Stroik was in here the other day and was giving me grief because I don't like foreign keys. To me, it's a business rule. You don't delete records that have children. If I tried to do that in my program, the database would yell, crash, and cause some kind of an exception that your program would kind of catch, and you'd try to figure out where the heck that was coming from. And you wouldn't know because your program isn't generating, it's a database. And so I don't do this. Put it in here so that you know about it. Here's the way it looks. At the end of a field, you designate it as foreign key. I'm sorry, at the end after the primary key, you designate the word foreign key, which field name is a foreign key and which one does it reference, and you have to list the other table name, and it works. That's for your information only. We're not going to implement. And I'm not answering any questions about it. If you have one, ask. This is also for your information only. Recently, in this batch of students, they discovered that there is a way for your database to keep track of the last time a record was changed automatically. I call it an audit field. Many customers of mine have asked for an audit field that keeps track of when was this record last changed. And in the past, I wrote code to say when I save, immediately put a timestamp in there to say that on this date, at this time, this record was changed. Most of my customers also want to know who did that. And so I'd store the user ID number or something in there. The user ID we can't capture automatically, but the timestamp we can. You define a field, just like we just did, of type timestamp. Notice that's different than date time. It's timestamp. And then you add a default clause. And the default clause says whenever you create a brand new record, put this value in there, and we call the now function, which is very similar to C#. Not only that, then there's an on update, meaning whenever this record is updated, save now in this field. So it will constantly keep track of the last date and time that the record, not the database, the record, the table, no, the record was changed. They discovered it. I don't want to forget it, so I put it in my notes. Not required for any of our databases in this class. It's just there for reference purposes. It's a pretty cool feature if your customer needs that information. Comes in real handy for records that got phone numbers in them. When was the last time this was changed? 1976. Okay, that's probably a landline. Because you could look and see that the data that we have for that has not changed in many, many years, or changed a couple of weeks ago. Occasionally comes in handy. And this information, it's a field, so we can later on ask for it. Show me any records that have been changed in the last 2 months. We can do that. It can come in handy, but again, we don't need it. Show tables. Let's just execute it real quick here, just as an example. Show tables gives you a list of the tables in the database. In the current database. I've done that once or twice in a GUI not a GUI, but in a business class program to find out what tables are available to me so I can show them. There are some people who write their own database manipulation programs because we could write a C# program that generates these tables. We don't need to use MySQL. We can use C#, we can use web programming, we can use VB, you can use any language and send the signal to the database saying, make me a new table. Or ask a question, show me what tables are in there. It's rare, beyond the scope of this course. But if you didn't have this handy dandy navigator over here, this might be handy. We've already seen describe. You can also do show columns from and then followed by the table name. Same thing as describe. But this next one I discovered one day accidentally, and it's pretty cool. Show create table marinas. I think I got that right. Show create table, yep. Sorry, keep pushing the wrong button. This is one big field that has the entire command that we use to create this table. Not really, it's reverse engineering it, because notice the not null in here. It's reverse engineering, it's looking at my current table definition, and this command returns to us the command to recreate it if we needed to. So we could save it, and I can share it with you, or I can email it to somebody. But this is one big, huge, ugly line, but you can still right-click it and copy it to the clipboard and send it to somebody. So if you're looking at somebody else's database and you want to see what commands would be used to create that, or you want to save it, you can do that. Never seen that before. I believe MySQL is the only language right now that supports that. SQL. The other MS SQL I don't think has that command. We've seen drop. All right, let's get on with it here. Adding data to a table. To add data to a table, we use the insert command. The insert command adds new records. Where? Who cares? This is relational database design. We don't care where the record is. This adds it to the end. The nice thing about relational databases is we can display the data in any order. In the order they were entered almost never means anything. So where it adds really doesn't matter, but it does add to the table and it adds it to the last row. But if you resort it in a different way, then it doesn't look like it's in the last row. To insert data, we have to tell it to insert into, and then the table name, and then a list of values. Normally I've been putting my values up here, the word values. And then for every field in the table, in the order that you defined them, so this down here would be pretty handy, because this is in the right order. Or if I need to, I could do a describe and see the field order. You provide values for every single field. So this table obviously has 1, 2, 3, 4 fields in it. Because if you use this version of the command, and there is a second version of this command, the insert command. If you use this version of the insert command, you must provide a value for every single field in that table in the order that they were presented. If you want to leave one blank, you can specify the keyword null. The values are surrounded by parentheses, very similar to the way we did fields when we were creating a table. So let's practice. Let's do one for fun here. Not all of this data is just bogus for trying stuff. All of these commands are pretty bogus too, so I'm just going to wipe them out. And now, let's put something into owners because it's relatively easy for us to figure out. Uh-oh. I'm changing gears. I'll explain why later. Let's go to service requests. I'm going to add record to service request. So down here I can see that a service request needs one integer, another integer, a description of some kind, a date, and then notice this got changed. It's hard to see from the back row, I'm sure, but it's a tiny int. Tiny int 1 bit, I think is what that means. Somehow behind the scenes, that's what MySQL says it translates Boolean into. But I still, when I create the tables, put in Boolean. We want to insert into service requests the keyword values, and then on the next line I start putting in my values in parentheses, and I usually just put them all in one line. So again, by looking over here in the navigation bar down here in the information part, I can see I need 1, 2, 3, 4, 5. If you leave any one of those out, you'll get an error. If you put them in the wrong order, put the date in first and then a couple integers, you'll get an error. I am a little bit choosy. I want you to prove to me that you know what these data types are. So you shouldn't be putting apostrophes around numbers. Integers should look like integers, just like the literals in C#, they should look like integers. And we'll talk about dates here in just a second. So if I'm following this guideline, the first thing I need is the service ID. Let's pretend it's number 1. And the owner, this is for owner, or the slip, number 1. They just need to be integers. In the future, we'll know that there is a service ID number 1. We'll know that there's a slip ID number 1, but right now we're just doing some practice inserting. The next thing I need to insert is a description. This is text. In MySQL, you may use either double or single quotes, apostrophes, doesn't matter. I tend to lean toward double because if my name has an apostrophe in it, then I can type the apostrophe. But what if you wanted to type in somebody's name, Harold, Harry with quotes around it, then you put apostrophes around it so you can put quotes on the inside. So they're interchangeable, but whatever you start with, you have to end with. So if you start with a double quote, you have to end the string with a double quote. And so here, let's just put in oil change. No automatic capitalization is done. Now, we're also breaking some rules here, right? I'm entering data into the database. Shame on us. We should have a GUI to do this. Well, we don't have time to write a GUI to do it. To learn the commands to enter data into the database, we have to do it manually. Normally, this is not something you do. Because later on, I might have an oil change with a capital C, and if you're anal like me, that could bother the heck out of you. We have to fix it. And if we automatically capitalize it using a GUI, we don't have to worry about that. Then we need a date. You have a choice when it comes to dates, but you must enter them in either case. You must enter them in ISO format, International Standards Organization format, which is 4-digit year, 2-digit month, 2-digit day, in that order. If you wish, you can put them in like this. I don't even know what date it is, 26. However, if you put the dashes in, you must put quotes around that. Otherwise, it tries to do subtraction and you get some really weird stuff. I don't think it allows slashes. If you're curious, go ahead and try it. If it works, fine. The other option that you have is still in ISO format, but without quotes and without dashes. That's legal. I accept them both, but I really like the dashes better. They're a little easier to read. They don't quite blend together. I see the number 150 there. It bugs me. I see 226. So the dashes to me make it easier to read, so I'm going to undo and put them back. But if you wish to put in your dates without quotes because it's easier to type, go for it. But remember, it's year, month, day, and everything must be 2 digits. It is not legal to leave out that leading 0. And finally, is this complete? That's the Boolean field. Here you have some choices. You can put in 0 or 1, where 0 is false and 1 is true. What I prefer to do is use the built-in constants true and false. So let's say that no, this has been scheduled, but it hasn't been done yet. This will insert one record into the table when we run it. So let's run it. And cool, I got one row affected and I got my green check mark, so that should have worked. But how do we test it? The easiest way to test your data entry is to ask for a list of all records in a table, and this is what that looks like. The select command we're going to focus on in the next 2 units. All right, we're going to do a little bit of select here, but just the bare basics so that we can check our work, and that's it. In the next unit, we'll get into all the different things we can do with select clauses. I want everything, so we put a star. Star represents all fields in this case. From, and then the table name. you'll get a list, and 1-1 oil change, date looks good, and complete. And now what's sort of cool, if I wanted to, I could say 2 and transmission work, and that was, and I'm going to test the date here now, see what happens.
You mean mass and transmission.
Cool, thank you. And let's say that this was done a while ago. Notice I'm entering a record backwards. This was done last month after I entered the one for the, doesn't matter. Doesn't matter. The database will store it, and later on in unit, whatever's next, I think we're on 2 here. In unit 3, we'll learn how to sort them the way we want them, not the way the database has got them. And let's say that one's done because it was last month. Enter it. And I could have just hit this button, right? Because then it would have entered it into the database and immediately also executed my select statement, but I didn't do that, so I'm going to do it twice. And now I got 2, and notice that even this date has dashes in it. No, it doesn't. Trust me. That's just how it's being displayed. Behind the scenes, MySQL is storing some magic number that figures out how many minutes ago from the dawn of time, January 26th is. It has some magic thing, and this is just the way it shows us to us humans, which is good for us humans. Notice also the trues and falses get converted to 0s and 1s. And so now we can just keep doing that, right? Except when you turn it into me, if you do it this way, you only get to see 1 at a time. Is there a way to enter multiple records at once? And the answer to that, of course, is yes. But I think before we do that, and I didn't put any nulls in, I could have. Here's a second version of the one you're more likely to use, the second version of the insert command. In this one, you list the field names that you want to enter the data in. I want to enter first name and then last name and then the date, or I want to put the Boolean in first and then I want to do it, and you can do whatever you want. You can rearrange the fields and enter them. Not only that, you can leave fields out. I want to put in 6 new camper records and I don't know what camp they're coming to. So, but I want to enter their data. If you don't enter a camper, if there's no camp number up here, it automatically puts in a null. This one is critical because if we're using auto number fields, which probably 90% of our tables are going to have, you can't designate, you can, but you shouldn't, designate the auto number. It just picks what's next. MySQL allows you to enter it and say, I want this to be record number 123. Don't you dare. The only reason you should be using that technique is to bring data in from a previous database that already has auto numbers, and I don't want to rebuild those. When you're adding new records to a database that has an auto number field, do not specify the auto number. If I want to skip it, the only way I can skip it, and I have to, Volker's rules, is to use this version of the insert command. So now let's put in some owners. So I'm going to click on owner. Clicking on owners here doesn't do anything except show me the owner information down here at the bottom. Okay. I don't have to select the table before I can insert it. I don't have to select the table before I can view what's in it. Just the database, not the table. So now I want to insert into this table. Insert into owners. And now, because it's got an auto number field that I want to skip, I have to list the fields that I want to insert. And just as an example, let's do first name, last name. This demonstrates, and by the way, the capitalization here doesn't matter of first name, last name. If you're anal like me and they're that way in the database, that's fine, but MySQL doesn't care. As long as you spell it right, it doesn't matter. What about the phone number? I'm not entering it, so it will automatically make all my phone numbers null unless some dummy put not null in the database. Then this message or this command fails. Doesn't fail. You don't get an error message. It goes, okay, I did it, and then it's not there, which is really annoying. Then I put in values. And let's put my name in there. And you have, since you're typing a manual, you have to type them properly. And if you wish, you can now insert another record. Comma. Next line, and maybe I ought to indent these. And let's put in Catherine Dorr. And you can keep doing this for 150 records or more if you want to. Just keep putting commas on there. But when you're done, put a semicolon after the last one. So that allows you to enter multiples all at once when you're doing your homework assignment. I said put in 4 sample records or something like that. You can put them all in at once, one command. And all you have to do is list the fields. Let's run it. This says 2 rows affected. Cool. And then underneath here, I can once again do that select star command from that table. And notice my auto number field has already got numbers in it, 1 and 2. And all the phone numbers are null because I didn't provide a value for them. Could I have? Sure. You just add phone number at the end here, and then you have to put phone numbers on the end of each one of those. Normally, you'll have all the fields up here. But if some of the fields you don't know yet and you want to add, you can add them and just leave those blank. You do not have to necessarily specify null. If you add a field and if you have a field up here and you want to leave it null, I'm not going to execute this, though I could. Oh, this is terrible. Don't follow. I could put, is it called phone? Yep, phone. And then here I could put null. And I'd have to put null. You have to put something here. If there's 3 fields up here, you got to provide 3 fields down here. What would happen if I executed this? It would insert 2 records into my table with Volker, Gall, and Catherine Dorr. Ben's going, oh my God, duplicate records. That's why I'm not going to press Control Enter. But it would do it. Because what's wrong with that? Nothing. It creates 3 and 4. It creates auto numbers 3 and 4. It says, okay, he said Volker and Catherine, here they are, and the phone numbers are null. And they don't all have to be null. Don't put dashes in there. We don't have room for them, right? Phone numbers are size 10. Don't put dashes in. If you make this too long, you put dashes in, you'll get a warning. It will fill in your data, but you'll get a warning saying I truncated your data. Gave me too much, so I quit when I was full. And it just chops off the end. And you get this phone number with 2 dashes and 2 digits at the end. So you have to remember those things. That gives you, for those of you who are getting bored, that gives you pretty much the information you need to do the next assignment. So let's go take a look at that and then we'll call it a day. Any questions? I'm sorry. Brains are getting full. It's been an hour and a half. Okay. Let's go take a quick look at the assignment. SQL build and populate. Oh no. Create an ERD. I thought we were done with that. Oh no, you need practice. I think. I don't know. I haven't seen too many of your database design 1s and 2s, but you need practice. You cannot get enough. So once again, you're going to build an ERD and a data dictionary. And that's part 1. When it's done, submit it. Because if you start doing all this stuff, the SQL for it, and your design is wrong, now you're going to have to go back and rebuild all that stuff. So my advice is do the ERD. This is basically database design 3, right? Then when you're done, provide the SQL to build these tables and give me 3 sample records that are fairly real world. This says use MS Word. I need to take that out. I don't want MS Word. I want a SQL file, a .SQL file. Send me that. Here's the table. Should be relatively decent. You have to do your own capitalization stuff. You should be able to figure out, well, you will figure out in your data dictionary how big these fields are. You'll have to figure out how they're linked. You should not need any additional tables. You're again kind of reverse engineering here. But in this case, it's a two-part assignment where you first send me the ERD and data dictionary, and then you send me the SQL from there. Let's put a due date on part 1. If I remember right, your part 2 database design is due on the 10th?
Yep. It's a lot of updates.
SQL build part 1. Ooh, there's also a lab. I forgot to look at that. Let's go take a look at that lab. Maybe I'll sign that first. Here's the SQL creating tables lab. I have not looked at it since last year, so what? Oh, it's a Word document. Come on, Reed's gone. There's no reason to be picky now. Please. Yeah, but I'm in charge here, not this lab. We finally got it. Start XAMPP, start the workbench, create a database called computer installs. Should show up. What command did you enter? Put it in here. Use the show command to show all the databases. Put the command in there. Make a computer installs your default database. Create a table. Know how to do all that, right? Put the command in here. Field designations are entered correctly from those. How do you know that you verified it right? Use the describe command. Man, I'm giving you answers here. Use the describe command, then take a screenshot so I can see it. Add a record, and so on. Screenshot. Using one command, enter 3 records. Just showed you how to do that. I like this lab. While all this is fresh, when you want to do. And don't say after the 10th, that's too long. So I'm now sneaking an assignment in between the other 2. Next week, before class, after class, before class Thursday, before class Tuesday. Lyle's doing all the talking, and I hope the rest of you chime in here pretty soon.
Yeah.
Thursday? Okay, so let's make this one due before class next Thursday. Actually, let's just make it due Thursday. The reason I say that is because I'm not going to be here next Thursday. So you will have tons of time to work on this. But I don't recommend waiting until next Thursday on the day it's due to start working on it, because if your flash drive fails, it's happened to a couple people, then you're kind of stuck. Maybe you can borrow somebody else's, I suppose. So for that lab, I'm going to assign that. We'll hold off on the build and populate assignment, but that's something you can start on, right? There's nothing magical. Nah, we're going to set the date for that too. So a week from today, anybody know? Is that the 5th? 6th? 5th? Thank you. Why am I asking? I got a calendar built into the program, dummy. 11:59. Let's go with a week after your other design for the SQL build and populate one, so that'll be the 17th. I would again not wait. We're getting close to spring break. You don't want to have a lot of all this stuff hanging over your head just before spring break, though before is better than during. So that should keep you hopping for a while. And again, I don't care about what my evil twins have assigned to you in the other classes. That's their problem. Remember, this is the linking table. You're registered in this class, so that's no relationship to your registration in the other class, which means there's no relationship between your assignments. I know, it gets busy, and it's not going to back off here anytime soon. And there's no campus dean to complain to.
At one time.
All right.